Hello, my name is Jacob Brower. I'm starting a mechanical engineering master's at Portland State University this fall, 2020.
My name is Kareli Ramirez Gonzalez. I'm currently a senior at Portland State University, and I'm going for a double major in physics and chemistry.
My name is Harvey Buckner. I am currently studying music and sonic arts at Portland Community College. I'm finishing up my second year.
I'm Hagerberg. I'm a mechanical engineering senior at Portland State University.
I'm Matt. I'm a sophomore studying computer science at Portland State University.
We're solving the problem of climate change. We're trying to lower the CO2 concentration in the atmosphere. Currently, there's about 36 gigatons of CO2 released every year, and that number is continued to expect to rise. There's also this problem in construction with buildings being too weak for, earthquake proof, for just regular like buildings collapse sometimes, even if everybody does their best job, to try to make everything up to standard. So we're trying to make stronger building materials. We're trying to make something that is carbon negative by using some new chemistries to make an alternative to an existing building material carbon negative. So our process more directly is that we extrude molten basalt into fibers, and then we do some carbon negative chemistry on them. It's called like a cold processing, because the basalt comes out at really, it's like a river of lava. It's molten lava. We're literally making lava. We're making lava into filaments, and then we're letting them cool, and then we're doing cold processing, which means they don't get red hot. It's still a little hotter than ambient temperatures, but it's not like 1400 degrees hot.
There's been quite a few challenges. I would say one of the more significant ones is probably, I think most people will say, is the pandemic. And so because of that, the university was closed, and we had a lot of gear in there that we needed, resources that we needed for building our machine that we lost access to, a lot of tools and equipment that we lost access to because of that. So that really has been one of the biggest challenges. But
dealing with remote communication, not being able to be in person in the same places and facilities that we usually would work. So a lot of things had to be separate and remote, and the team was a lot more separated.
Aside from the obvious quarantine struggles that I'm sure every team has gone through, we have a problem with narrowing our focus. Keeping our scope narrow has been an issue that we've struggled through.
I think the most valuable thing I've learned through the program is that I am an actual scientist. It's easy, like when you're in school, to feel like, do I actually know what I'm doing? And you have all these things going on. But to be able to create and manage, especially during this time, to manage with few resources and all these delays, I'm like, wow, okay, I actually know quite a bit more than I thought. And there's nothing like working in the field that you love. So I would say that the best thing I've learned is just to be more confident in myself as a scientist and as a team member.
Depending on how much the scaling approach happens, if we are able to take over like 10% replace 10% of the steel rebar market in the United States, we're going to be able to decrease the amount of CO2 in the world budget by like 2%, which is a lot. That's like a sizable, impact.